Okay, let's just look at the example 2. So in example 2, you have to convert this non-homogeneous into homogeneous. So you will have to get your YC. So, okay, so just let this differential equation equal to 0. And change the derivative into m. So you have m squared minus 4m plus 3. And you factor it, you will have m minus 1 and you will have m minus 3. And this will give you m1 is equals to 1 and m2 equals to 3. So since the value of m1 and m2 are different, means that you will have your yc will be in the form of a, e, and 1x plus b, e, and 2x. Okay, so you have your yc. Okay, your a, e. Okay, well, m1 here is 1. So 1 multiplied with x will give you x. And we have b, e. Okay, m2 is 3. So we have 3 multiplied with x. So you have 3x. So this is your yc. And let's just figure out what is the yp. So you need to get your yp. So the trial solution yp will depend on the form of the function f. So this is your function f. So your function f is 6x. So since that you have a polynomial here, this is x power 1, then your yp will be a polynomial. So okay, and this is x power 1, then you will have a linear equations for yp. So that is begin with the c, then we have dx. Okay, it should be x power 1, so you have to follow the form of the function f. Okay, now before you continue to differentiate it, let's just check the form of yp and yc. Okay, so what you have here is your yc is exponent, but your yp is a linear equation. So it means that they are different. When they are different, means that you do not have duplication in this case. When you do not have duplication, then only you're allowed to continue to differentiate the yp. Okay, so let's just differentiate the yp. So the c here is actually a constant. You differentiate a constant, we have a 0. If you differentiate dx, it will give you d. And then let's just differentiate some more. We have y double prime, and then this one is a constant. You differentiate a constant, will give you a 0. And then the next thing that you have to do is you have to do the substitutions. You have to substitute your yp, y double prime, y prime, and y into into where? Okay, into your non-homogeneous equations. Okay, that is this one. This is the non-homogeneous equation. So let's just name this non-homogeneous equation as equation number 1. So let's just substitute into equation number 1. So you will have, okay, this one is the y double prime. Your y double prime is actually 0. Minus with 4. Multiply with the, this is actually your y prime, that is d. Okay, and then plus 3y plus 3y. Your y is c plus dx. So c plus dx. Okay, and equals to 6x. Okay, let's just expand this one. This is d here. This is d. Okay, so okay, let's just expand this one. So we have a negative 4d plus 3c plus 3dx equal to 6x. Okay, let's just compare the left hand side and right hand side. So if we compare the left and right, okay, let's just compare the variable x first. Okay, so let's just compare the x. Okay, if you compare the x, so you for the left hand side, you see that I have 3dx. For the right hand side, I have 6x. Okay, we just have to focus on the coefficient only. So for the x, the coefficient set that you have for the left hand side, we have 3d here. For the right hand side, we have 6x. We just have to focus on the coefficient, so we have 6 here. So your d here is actually equal to 2. Alright, so let's just look at another one that is let's say look at the constant. Okay, so let's just look at the constant. So look at the constant. So for the left hand side, okay, so the constant that you have here is negative 4d plus 3c. But for the right hand side, obviously we do not have a constant here. We do not have a constant here, means that it's actually equal to 0. Okay, now you can solve this one because you know that what is your d here. Your d here, the value of d is actually 2. And then you're going to solve this one. Okay, so you will have 3c equal to 8, and your c is actually 8 over 3. Okay, let's just substitute, okay, your value of c, that is 8 over 3 into, okay, into your yp. So where is your yp? Oh, we have the d also. Yeah, we have the d also here. Okay, we have the c and we have the d also. Our d is 2, okay, into your yp. So where's our yp? Your yp is, this is the 1. So we're going to substitute into here. So we have yp equal to, the c here is 8 over 3 plus dx. Your d is 2x. Okay, this is the yp. Now let's just move to the general solution. So for the general solution, you will have y equal to yc plus yp. So what is your yc? Your yc, this is the 1. So you have a e x plus b e 3x. Okay, plus with your yp. So this is your yp. So you have 8 over 3 plus 2x. Okay, so this is the general solution for the example 2. Okay, let's just look at the third example. Okay, so again, so we're going to change this one into the homogeneous equations. So here we have the equations. Okay, this one, these differential equations will be equal to 0. Okay, and then you have to convert the derivative into m. So then you have the m squared plus 3m plus 2 equal to 0. And let's just factor this one. Okay, if we factor this one, we have m plus 2 and m plus 1. And we have my m1 as negative 2 and m2 as negative 1. Alright, okay, then this is two different m. Okay, so this means that you have real and distinct roots. So then you're going to have your yc. You're going to have the form of a e m1x plus b e m2x. Okay, let's just substitute. So you will have your yc. So that is a e m1. m1 is negative 2x plus b e negative x. Okay, so this is your yc. So let's just figure out our yp. So we need to get your yp here. So your trial solution yp will have to depends on the form that we have here. So this is actually your function f. Okay, so your function f is 2e minus 4x. Okay, so this function f will tell you the form of the yp. So you can notice that actually your yp is supposed to be c e minus 4x. Okay, before you continue, okay, to differentiate this yp, okay, let's check. Okay, let's check, do we have the duplication in here? Okay, your yp here, you have exponent, but this exponent is e to the power of negative 4x. But this is also exponent, but this exponent is e to the power of negative 2 and e to the power of negative x. Okay, so they are different because the power here are different. Okay, so this is negative 4, but this is negative 2, negative x. So means that you do not have duplication. So when you do not have duplication, means that you can continue. Let's just continue to differentiate. Okay, if you differentiate this one, you will have y prime. So differentiate on an exponent will give you negative 4c e minus 4x. Okay, differentiate one more time. Okay, so you have the exponent here, right? Okay, so you differentiate the exponents, it will give you negative 4 exponent. Okay, multiply with this negative 4c will give you 16 ce minus 4x. Alright, this was y double prime. Okay, so once you have obtained your y double prime, the next thing that you have to do is you have to do substitution. So you're going to substitute your y double prime, your y prime, and your y into your non-homogeneous equations. That is this one. Okay, this is the non-homogeneous equation, so we name it at equation number 1. So let's just substitute into equation number 1. So you can have y double prime. So y double prime is 16. So you have 16 ce minus 4x plus 3y prime. So plus 3y prime. Your y prime, okay, this is the one. So you have negative 4 ce minus 4x plus 2y plus 2y. So the y here, that is ce minus 4x, okay, equal to 2e minus 4x. Alright, okay, let's just expand this one first. So you will have 16 ce minus 4x. This give you 12 ce minus 4x, and this give you 2 ce minus 4x. Okay, and let's simplify it. Okay, so you can see that basically all of them, all of the terms that we have here is actually we have the ce minus 4x, ce minus 4x, ce minus 4x here. So means that basically you can just take note on the number. Okay, you can take 16 minus 12 plus 2. Okay, because all of them are the same terms here. So if you have 16 minus 12 plus with 2, okay, then you will have 6 here. You have 6, okay, together with the ce minus 4x. Okay, this is for the left hand side. Okay, for the right hand side, we just have to rewrite back. So we have 2e negative 4x. Now let's just compare the left hand side and right hand side. So if you compare the right hand side and left hand side, okay, we are comparing on the e minus 4x, e minus 4x. Okay, so you're comparing on e minus 4x. Okay, if you compare the e minus 4x, okay, the things that you can see for the left hand side is actually you have 6c. For the right hand side, you have 2. This means that your c here is actually equal to 1 over 3. Okay, so once you obtain your value of c, okay, then we're going to do substitution. So you're going to substitute your c, that is 1 over 3 into your yp. So you're going to have your yp, okay, so your yp will be this one. So you will have c, the c is 1 over 3 e minus 4x. So this is your yp. Now let's go to the general solutions. Okay, your general solution will be the result of y equals to yc plus yp. So y equal to yc, this is the yc, so you have a e minus 2x plus b e minus x plus with yp. So this is your yp, so this is 1 over 3 e minus 4x. So this is the general solution for the example number 3. Okay, let's look at the example 4. Okay, in example 4, you have the non-homogeneous equation. So let's just convert it into homogeneous equations. So you will have this one. Okay, and just have to change this one into let's just look at the example 4. So just change this non-homogeneous equation into homogeneous just that you can get your YC. So what you have to do is just let this one equal to 0. Okay, then this what we have here. Okay, then for the derivative, okay, the derivative here you have to change to m squared. So this is actually not derivative, therefore we do not have the m here. So rearrange it, we have m squared equal to -1. And this one, if you square root both sides, that will give you m equal to square root -1. Okay, square root, okay, so the square root here will give you a plus minus. Okay, and the root, square root -1 is actually equal to I. So this is actually the I here. So therefore you will have your m equal to plus minus I. Okay, then you're going to compare your m, okay, with the general form of the complex conjugate, that is m equal to alpha plus minus beta I. Okay, if you look at this one, okay, so you can note that your alpha here, that is actually 0. Okay, your beta here is the one that is next to I, so this is 1I, so your beta is actually 1. Okay, since you are having since that you're having complex conjugate roots, means that your YC is supposed to be in this form, and you're going to substitute your alpha into here, so your alpha is actually 0, and your beta is actually 1, so you have 1 multiplied with x will give you x, and same thing happened to here, and e to the power of 0 is actually 1, so then we have, this is your YC. Okay, the next thing that you have to do is you have to figure out what is your YP. So your YP actually depends on the function f. Okay, so this is your function f. So okay, if you look at the function f, you must know that your YP supposed to be in term of pair. So we have c sine 2x plus d cos 2x. Okay, when you have sine, you must have the cos. Okay, before you continue to differentiate this YP, check for the duplications. Okay, so if you look at the YP and YC, both of the solution are having the sine and cos, but the angle in the YP that you have here is actually 2x. The angle that you have in the YC is actually x. So we know that the x is actually different with 2x. Since that they are having different angle, means that they are different terms. Okay, even though that you have the sine and cos together, but because of the angle are different, so you have different terms. When you have different terms, means that you do not have duplication in here. Okay, when you do not have duplication, then you can differentiate this YP. You can continue to differentiate. Okay, let's just differentiate it. Okay, let's just look at the sine 2x here. Okay, so if you look at the sine 2x here, so if you differentiate on the sine 2x, okay, so this is give you 2 cos 2x. Okay, 2 cos 2x, you multiply with c, will give you 2c cos 2x. Okay, the same thing happened for the cos here. So if you differentiate the cos here, will give you negative 2 sine 2x. Okay, so negative 2 sine 2x you multiply with d, this is the one. Okay, this is the result. And again, we're going to do the differentiation again. So we're going to differentiate this cos 2x. Okay, so if we differentiate this cos 2x, okay, this is give you negative 2 sine 2x. So this multiply with 2c will give you negative 4c. Okay, and then differentiate on sine 2x will give you 2 cos 2x. Okay, so multiply with negative 2d, so we have negative 4 cos 2x. Okay, so this is your y double prime. Okay, now, okay, the next thing that you have to do is you have to do substitution. So you have to substitute all the things that you have here into your non-homogeneous. That is, this is the one. Okay, but if you look at here, okay, the things that we have here is we just need the y double prime and the y. Okay, so let's just name this one as equation number 1. So we just need to have the y double prime and y only. So let's just substitute the y double prime into here. So if you substitute, I would have, this is the one, okay, plus with y, okay, your y, okay, this is the y, okay, so we have, this is the thing, okay, and equals to 12 sine 2x. All right, okay, let me erase this one. All right, okay. So let's just simplify the terms that we have here. Okay, what you have here is you see that I have sine 2x and I have sine 2x here. So then you can focus on the negative 4 plus c. Okay, so negative 4 plus c will give you negative 3c sine 2x. Okay, then let's look at the cos 2x. For the cos 2x, okay, you have cos 2x here. So it means that you have negative 4d plus d, then that is give you negative 3d. For the right hand side, we have the same thing. Okay, then we're going to do the comparison. We're going to compare the left and right. Okay, let's just look at the sine 2x. Okay, for the left hand side, you have sine 2x. Okay, for the right hand side also you have the sine 2x. But for the left hand side, the things that in front of the sine 2x is actually negative 3c. For the right hand side, you have 12. Okay, so you simplify, we have your value of c that is actually equal to negative 4. And then let's just look at the cos. Okay, for the cos here, okay, so we compare the cos. Okay, for the left hand side, what you have here is you have left hand side is negative 3d, but for the right hand side, obviously we do not have cos. Okay, so when you do not have cos, it's actually equal to 0. Okay, then you will have your value of d is actually equal to 0. Now substitute your value of c and d into your yp. Okay, so substitute it into your yp. So this is your yp. You're going to substitute into here. Okay, your value of c here is actually negative 4. So you have negative 4 multiplied with sine 2x. Okay, and then plus d cos 2x. D here is actually 0. So you 0 multiplied with cos 2x will give you 0. So you plus with 0. The things that remain is this one only. Then you will have this only for your yp. Now once you have known your yp, the next thing is you have to figure out your general solutions. Okay, so this is the general solution, y equal to yc plus yp. So you have y equal to yc. So your yc, then this is the 1. Okay, then we have yc here. Plus with yp. So your yp, this is the 1. Okay, then we have your yp here. So this is the general solution for the example 4. Okay, let's just look at the example number 5. Okay, so first of all, change this one non-homogeneous equation into homogeneous equation just that you can get your yc. So what you have to do is just have to let this differential equation equal to 0 and just have to change the derivative into m. So then this is what we have here. Okay, so if you factor, and you will get your value of m1 that is negative 2, and you will get your value of m2 is negative 1. And since you are having different value of m, then your value your yc is supposed to be in this form. So in here, your m1 is negative 2. So negative 2 multiplied with x will give you negative 2x. M2 is negative 1. So negative 1 multiplied with x will give you negative x. So this is your yc. Okay, the next thing that you have to do is you have to figure out your yp. So to get your yp, that is actually depends on the form of the function f in here. So your function f is this is the one. Okay, and if you look at the function f that we have here, your yp is supposed to be in this form, that is c e negative 2x. Okay, before you continue to differentiate this yp, again you need to check for duplications. Okay, if we're looking at the yc and yp, okay, in yc you can see that I have the e negative 2x, and yp I also have e negative 2x. It means that I have the duplication in this case. Okay, because you have the same term here, so we have e negative 2x, we have e negative 2x. When you have the duplications, okay, so please do not continue to differentiate it. Okay, so when you have duplications, what you have to do is, okay, when you have duplication, you have to modify this yp. Okay, so you have to multiply this yp with x power 1. Okay, so let's just see, okay, what happened if we multiply this yp with x power 1. Okay, so if you multiply this yp with x power 1, okay, this is what we have here. And let's just compare the result that we have here, okay, with this with the yc. Okay, now what you have here is you have xe minus 2x. Okay, so you have xe minus 2x. Obviously xe minus 2x is different with the e. So since they are two different terms, means that, okay, you have settled the problem of duplications. Okay, so the correct yp must be this one. This is the correct yp. Okay, so okay, then we're going to use this yp in order to solve the next thing. Okay, let me erase this one. So this is the correct way. You're going to use this one in order to solve the questions. Okay, so now, okay, let's just differentiate this yp. So if you want to differentiate this yp, so you're going to use the product rule, okay, because you have the cx here. So this is actually your u, and you have your v here. Okay, so you're going to have your product rule to differentiate. Okay, so you will have your y prime, okay, equals to u dv plus v du. So now your u here is, this is the one that is cx, okay, and multiply with your dv is actually negative 2e to x, okay, plus with the v, this is the v, okay, multiply with du will give you c. Okay, now let's just simplify this one. Okay, so if you simplify, okay, that is our y prime. Okay, again, so you have to differentiate again. If you differentiate again, okay, what you have here is you also have to use the uh, product rules, where you have the u here and you have the v here. Okay, so your product rule, okay, so in here you have u dv, you have u dv plus v du. Okay, so okay, let's just differentiate it. So if you differentiate it for y double prime, for your u, you will have this negative 2cx. Okay, du you will give you negative 2e to x, negative 2x, okay, plus v. The v here is the exponent, multiply with du, your du is negative 2c. Okay, and do not forget we still have ce negative 2x here. Okay, where your ce negative 2x here, you have to differentiate it. So if you differentiate this one, this is basically give you negative 2ce negative 2x, right? So then this is actually, this is the one. All right, okay, let's just simplify it. Okay, so if you simplify it, this is what we have for the y double prime. Okay, expand it. Okay, and you can see that I have the same term here, e negative 2x, e negative 2x. So you can group these two together, it becomes negative 4c. All right, that is our y double prime. Okay, once you have obtained your y double prime, the next thing that you have to do is you have to do the substitutions. You're going to substitute all the things that you have here into your non-homogeneous equations. Okay, so let's just name it as equation number 1. So let's just do the substitutions. Okay, so you have y double prime. Okay, so your y double prime, that is, this is the 1. Okay, so we have here, okay, plus with 3, plus with 3. Okay, y prime, so this is your y prime. Okay, and then plus 2. Okay, multiply with y. Okay, so this is your y. Okay, equals to 3e negative 2x. All right. All right. Okay, so let's just look at this one. Okay, so let's just expand the term at the back. Okay, so this one you can rewrite back. Okay, this one you can expand it. Okay, so expand, you will have this one. Okay, and expand it, you will have this one. And for the right hand side, we just copy back. Okay, and now we try to group the same terms that you can see in here. Okay, so let me see that, let me use the blue color. Okay, so in here you can see that I have the xe negative 2x, I have the xe negative 2x, and I have the xe negative 2x here. So they are all the same terms. So since they are all the same terms, actually you can focus the terms, the things that in front of it. Okay, so we have 4c, you have minus 6c, okay, and you have plus 2c. Okay, so this is actually for xe minus 2x. Okay, so 4c minus 6c plus 2c actually give you a 0. So you have a 0 multiplied with xe minus 2x is actually give you a 0. So you don't have to write the 0. Okay, then let's just look at another term. Okay, let me use another color. Okay, let me use this one. Okay, so you have e only. Okay, you have the exponent only. Okay, so for the exponent only, if we look at the exponent only, so we have negative 4c here, and we have plus 3c. Okay, that is for the exponent. So you have exponent negative 2x. Okay, so negative 4c plus 3c will give you negative c e minus 2x. Okay, so therefore we have the next line for the left hand side. Okay, for the right hand side, we just have to write back. All right. Okay, so now we're going to compare left and right. Okay. So okay, for the left hand, okay, so we're going to compare on the exponent. So exponent e minus 2x. Okay, for the left hand side, you can see that I have minus c. For the right hand side, I have 3. So it means that your c is actually equal to minus 3. Once you know your c is minus 3, substitute into your yp. So this is your yp here. We're going to substitute into here. So your c is actually negative 3. So you have negative 3x e negative 2x. Okay, this is your yp. Now let's just figure out our general solution. So our general solution, we're going to use this formula. So y equals to yc. So your yc, here we are. We have our yc. Okay, plus with the yp, or your yp. Okay, this is the one. Okay, then we have, okay, this is the one. So we have this as the general solution for the example 5.